we've got a lovely integral today. We're going to integrate e to the x multiplied by 1 plus e to the 2x, all square rooted. So first thing to note, our e to the 2x is the same as e to the x squared, using the power laws. And now then we'll do a u sub. We'll have that u is equal to e to the x. So du is equal to e to the x dx, which we can see is going to appear here and here. So these bits are all gone, lovely jubbly. And all we're left with then is the integral of 1 plus u squared, all square rooted, integrated with respect to u. So now then, we're going to do another substitution. We'll say u is equal to sine of y. The reason we're doing that is because of the hyperbolic trig functions and their identities. We have cos y squared minus sine y squared is equal to 1. So if you add sine y squared over, we know that that's going to be cos squared. So this entire bracket will simplify down to simply be cos. If we integrate now, differentiate our du with respect to y, what we're going to get is just cos of y. So we can say then, lovely jubbly, our du is equal to cos y dy. And sticking this all together then, we know our square root is just cos of y. Our du is going to be cos of y dy. So what we can say, our entire integral is now just going to be cos squared y dy. So to integrate this, we use the double angle formula for hyperbolic functions. So we know that cos squared y is equal to a half of cos 2y plus a half. So we can stick that in instead. Our integral is going to be a half cos of 2y plus a half integrated, still with respect to y. The half will be nice and easy at the end. That will become just y on 2. And the cos will actually integrate to give us sine. So we're going to have, or half of sine even, sorry. So we'll have a quarter of sine 2y plus y on 2. And we'll have a plus c on the end. And now then, we'll go and try and stick everything back in again. We might need to use double angle formula again though, where we've got this sine 2y. We only had sine y there. So we'll try and write this out in terms of sine and cos instead of with like 2y, just with a single y. So if we rearrange this formula up here, we can try and find what cos is. So we know cos of y is going to be equal to 1 plus sine squared of y, all square rooted. Which in terms of our u, looking at this bit, that's 1 plus u squared, all square rooted. Using another double angle then, we have that sine of 2y, in a similar way to sine, is 2 sine y cos y. So sticking that all together, we've got a quarter of times 2, so just a half, of sine y cos y plus y on 2, which we'll leave for a second, and now we'll replace all the y's. So our y, if we arrange this little bit, is going to be inverse sine. So sine to the minus 1 of y. So altogether then, our sine y is now u, so that's a half of u. Our cos y is now 1 plus u square rooted, or 1 plus u squared square rooted. And our y on 2 is going to be a half of inverse sine. With u in there, sorry, not with y. Whereas up here I put a y as well, so we'll just change that to a u. That's a u, and still a plus c on the end. And now then, we'll replace the u. So we get a half e to the x multiplied by 1 plus e to the 2x, all square rooted, plus a half of inverse sine to the e to the x, still with a plus c on the end.